All right, y'all. Happy Friday. Hope you're doing well. I have asked your sub to go ahead and give you the next set of papers for your glossary. This is going to be chapter 6, all on quadratics, and there are 8 papers. My intention for today is to give you some time to get caught up on your glossary and take a look at a couple of pages from chapter 6. So let's just look at each of these. Page 1 is just factoring a simple quadratic trinomial. So let's go ahead and work through an example together just to make sure we're all on the same page. For number 1, x squared plus 20x plus 51. You're looking for numbers that multiply to 51 and add to 20. Now, the answer is just going to be something like this. Now, numbers that multiply to 51 and add to 20, I'm thinking positive 3 and positive 17. And that's it. That's your answer. Maybe off to the side, something that would be good to write is that we were looking for numbers that multiply to 51 and add to 20. So I'd be tempted to write something like this. What times what equals 51, and what plus what equals 20. And the magic numbers were 3 and 17. It may also be a good idea to make note of what those sign operation or sign rules are. So if it's ax squared plus bx plus c, your factors will be both positive. If it's ax squared minus bx plus c, your factors are going to be both negative. And so on. Literally just what's written on the board. So just think about different ways that you could express what you know in order to factor the rest of these. Over here, all I'm really looking for is the 2 factors. Definition, factoring a polynomial. I'll go ahead and give you a little head or leg up on that. Factoring a polynomial is just rewriting a polynomial of a high degree as the product of 2 or more low degree polynomials. What I mean by that is if I look at number 1, this expression, this polynomial, had a degree 2 because the highest exponent is 2. We rewrote it as the product of 2 degree 1 polynomials. So I'll give you a second to get caught up on that. Okay. Looking at 6.02, these are all about special cases. So I'll go ahead and jump down to the definition. A perfect square trinomial is a trinomial with 2 of the exact same binomial factors. Difference of squares is a trinomial that's missing the middle term. Its product is a negative perfect square. And it adds to 0. And so sorry for how loud it is. One of our custodial staff is buffing the floors right outside my room. So really one thing I want you to focus on is how do you know what is what? How do you know if you've got a perfect square trinomial or the difference of squares? Let's look at a couple of examples together. This first one, x squared minus 10x plus 25, this is a perfect square trinomial. And I know that because if I try to factor x squared minus 10x plus 25, I'm going to get x minus 5 times x minus 5, which could be written as x minus 5 squared. It doesn't matter which way you write it, but the fact that it's got two of the exact same factor means that it's a perfect square trinomial. Again, you still want to express how do you know that it's x minus 5 and x minus 5 over here. Number 2. This one is the difference of squares. How I know that is I've got x squared minus a perfect square. Now, this one could have been written as x squared plus 0x minus 64, which is why I know the factors are x plus 8 and x minus 8. Also, the square root of 64 is 8. So, all of these difference of squares just end up being the square root. Number 3 has a GCF. The way I know that, first and foremost, both of these numbers are divisible by 5. But they also have an x. So I can divide a 5x out and rewrite this as 5x times x plus 4, where 5x is my GCF and x plus 4 is just what's left over. So, make a note over here about how you knew to divide out a 5x. How would you know looking at this that 5x is GCF and you can't go any further into x plus something times x plus something? Okay. Number 3. Factoring where the leading coefficient is something other than 1. The leading coefficient is just the coefficient in front of the highest degree term in a polynomial. For example, 6 is the leading coefficient, 2 is the leading coefficient, 30 is the leading coefficient. And we want to completely factor these expressions. Now, you always want to check to see if there's a GCF first. But 6, 1, and negative 12 don't have a GCF. So there's not one here. So I'll start the slide and divide method. Which is where I'm going to take this 6 and multiply it times negative 12 and rewrite this as x squared plus x minus 72. Then I can find factors of negative 72 that add to positive 1. Because it multiplies to a negative, the signs are mixed. And the combo that works is positive 9 and negative 8. Then I need to divide them both by 6. Both these fractions can be reduced. 9 over 6 reduces down to 3 over 2. 8 over 6 reduces down to 4 over 3. So those factors reduce to x plus 3 halves and x minus 4 thirds. And then I can pull both those denominators up front to finish with 2x plus 3 times 3x minus 4. So a really good idea on how you can get some more credit over here is to explain the slide and divide process. I just did it for you, but just because you have all this written down doesn't mean you know what you're doing. And just a hint, make sure you check for a GCF for all of these. There's at least one on this paper that has a common factor that you need to divide out first. Otherwise, you're going to have a really tough time factoring. I'll give you a second to get caught up on this. Okay, look at number 4. The difference between 6.03 and 6.04 is we are solving the equation. Now, to solve a quadratic equation by factoring, it must be in standard form and must be equal 0. Well, example 1, it'n't. So I am going to rewrite this. I want to cancel out the 23x and the 2. So I'm going to subtract 23x. And because I can't take 23x away from 4x squared or from 17, I'm just going to squeeze it in the middle. That gives me 4x squared minus 23x plus 17 equals 2. Then I'm going to subtract 2. 2 and 17 are like terms, so I'm going to subtract 2 from 17. (17 minus 2 is 15, and that's canceled everything out on the right side, so it equals 0. Now I can go ahead and factor. There is no GCF between 4, 23, and 15, So I'll go ahead and start the slide and divide process. Rewrite this as x squared minus 23x plus 60 equals 0. I'm finally ready to find the factors of 60 that add to negative 23. Those will be negative 3 and negative 20. Now, x minus 3 gives you a factor of x equals 3. Let me say that again. A factor of x minus 3 gives you a solution of x equals negative 3. A factor of x minus 20 gives you a solution of x equals 20. Finally, divide them both by 4. 3 divided by 4 is just 3/4, or 0.75. 20 divided by 4 is 5. Definitely make sure you're showing all your work here. Off to the side, a really important thing to express is, how did I know to go from x minus 3 to x equals 3 and x minus 20 to x equals 20? Why did I just switch the signs there? It has something to do with x minus 3 equals 0 and x minus 20 equals 0. The zeros of a polynomial are just the solutions to the equation when it equals 0. And zeros can also be called your roots, your x-intercepts, or your solutions. Those 4 terms are used interchangeably: zeros, roots, x-intercepts, and solutions. Okay, 6.05. Love this one. Solving a quadratic equation in context. Number 1 says Harold launched a model rocket out of his bedroom window. The height, h, and feet of the model rocket can be determined using the function ht equals negative 4t squared plus 10t plus 14, where t is the time in seconds since the rocket was launched. How long does it take for that rocket to reach the ground? If the rocket is on the ground, its height off the ground is 0. This is just a long-winded way of asking you to solve the equation negative 4t squared plus 10t plus 14 equals 0. Little hint for this first one. Divide out that GCF of negative 2 before you do anything else. I knew it was negative because of the negative in front of the leading coefficient, and that takes this down to 2t squared minus 5t minus 7 equals 0. Then you'll start your slide and divide process. Now, you are going to get 2 answers here. Perhaps both of them make sense, or perhaps only one of them makes sense. You should definitely explain over here why, if only one of them makes sense, you're going to toss out one of your 2 answers. So that would be a great explanation for over here. For number 2, where it says f of x equals g of x, it literally just means this equals that. So set this equal to that, and then solve by factoring. You'll need to make it equal 0 first. And there's no definitions on 6.05. So finish up number 1, explain, set these 2 equal to each other. Okay. 6.06, writing and solving quadratic equations. So on the last one, you didn't have to write the equation for yourself. This one you do. So number 1, for some value or values of x, twice the square of x is equal to 1 more than x. Identify the values of x for which the statement is true. So twice the square of x. It's just a fancy way of saying 2x squared. 1 more than x is a fancy way of saying x plus 1. So apparently, 2x squared equals x plus 1. Identify the value or values for which the statement is true. Number 2, Ben opened his own bakery. He designed a small flyer that's 5 inches long and 4 inches wide to advertise his business. He plans to scale up the design of the flyer to use as a larger poster on his storefront. He'll enlarge both the length and width of the flyer by the same amount in order to create a poster with an area of 600 square inches. What are going to be the final dimensions, length and width of Ben's poster? So I'm going to draw a little picture here. This was 5 by 4 to give us a rectangle that's 20 square inches. And now we're going to have a much larger rectangle that has an area of 600. And what he's going to do is he's going to tack on some extra to both the length and width. But we don't know what he's going to tack on. So this is going to be 5 plus something to give you this. I'll call that 5 plus x. This is going to be 4 plus something to give you the width. So I'll call that 4 plus x. You'll need to solve the equation 5 plus x times 4 plus x equals 600. I am totally fine if you use Desmos to solve this equation. In fact, I'd recommend it. But if you just say that the answer is x equals whatever, you're not going to get full credit. Over here, I 110,000% need you to explain what you did in Desmos in order to get your answer. Also, be careful. It wants to know the final dimensions, the length and the width of Ben's poster. And no definitions. So, solve number 1, solve number 2, explain how you do it. Number 7. Wanting to kick a soccer ball, the function h of t shown below, it's really shown over here, gives the height h in feet of the soccer ball after t seconds. The graph is shown to the right. Oh, the function shown below, right there, the graph shown over here. So identify the key features and the meaning. So the y-intercept is where it crosses the y-axis. Explain what that y-intercept means, not just the ordered pair, but what each of those values means. The x-intercepts, right here and right there. Axis of symmetry is that vertical line across which the parabola is a mirror image of itself. The vertex is this highest point up here. Is the vertex a minimum or maximum? Minimum will be a high point, maximum will be a low point. Down here, explain what the vertex of a parabola is and what the axis of symmetry of a parabola is. And 6.08, determine the vertex coordinates algebraically. I do not want you to just type this in Desmos and say, hey, the vertex is this, comma, that. You need to do it by hand. You're welcome to use Desmos to check your work, but the steps are all laid out for you. Solve this. So 4x squared minus 20x plus 21 equals 0. Factor the function to determine the roots. Find the average of the roots. So once you get x equals this and x equals that, add them together and divide by 2. Step 3. Whatever you get for step 2, let's say the answer is -5. It's not. Plug -5 in for x here and there. That will give you the y-coordinate for your vertex. So whatever answer you got from step 2 is the first value. Whatever answer you got for step 3 is the other part of your vertex. And no definitions. Okay. I want to give you just the rest of class to work on your glossary. So, if you need to get caught up on anything from chapter 5, go ahead and do that. Remember that 5.07 is due today. 5.08 will be due on Monday of next week. And then you'll start seeing chapter 6 due starting Tuesday of next week. So 6.01 is due Tuesday of next week. Y'all are welcome to work together, move around the room. Just make sure that you are being honest and, integrity and all that, and not copying each other's papers, because I can tell and I'm judging you. Anyway, hope you have a wonderful rest of your day. Have a wonderful weekend, and I will see you on Monday. Take care. Bye-bye.